Okay, welcome everybody to the July 19th, 2018 Kubernetes community meeting. This is a recurring meeting where you can sort of get your one-stop shopping on happenings across the community, updates on things that are going on. As with everything in this community, we are open and sharing and collaborative. I'd request everyone to keep that in mind and be constructive and thoughtful, courteous, and give that the type of courteous that you would personally respect to everybody who's presenting and speaking today. And also this will be recorded. We're actually streaming live to YouTube right now. So between that and the recording that will be posted later to the internet as well, your actions and comments are public and reflect on you and our community as a whole. So please keep that in mind and keep it positive and constructive. I am Tim Pepper. I work in the Sig contributor experience and Sig release, and also happen to work for VMware as well. I'm your moderator for the meeting today. We've got a volunteer note taker, Solly Ross. If you'd like to contribute to note taking as well, the Google Doc is linked off of the meeting invite. And if you're interested in volunteering in the future for moderating this meeting, please reach out to Sig Contribex in Slack. We are a volunteer community and would appreciate everybody who contributes to that. So today's meeting, we are starting off with a demo of MicroK8s, and hopefully I'm pronouncing that right. And Marco Seppi is going to present, so I'm going to hand it off to him.
Hey everyone, thanks Tim, thanks all for having me here. I just want to briefly walk through a project that's spun up about a month or two ago. It's called MicroK8s. Oh man, I hope the Zoom interface doesn't show up my screen share. It probably does because this is Linux. Close enough. All right. So MicroK8s, microK8s.io. There's also a Slack channel, #MicroK8s in Slack. The genesis of this whole project was to build a really lightweight desktop installable Kubernetes that was what you would expect from like a fully conformant Kubernetes system, but in the lightest, most isolated way possible. So this project is driven by a technology called Snaps, which is a kind of like a package style containerization format. So think of a lot of the primitives that are leveraged by containers today, strip away a lot of things that you don't need, like isolation and namespacing of the TCP/IP stack and other pieces where you kind of run one copy of one software per machine. That's really what Snap packages are. So I'm just going to quickly install this Snap on my computer, kind of show how quick it is to get an isolated Kubernetes cluster running and how easy it is to throw away or reset that cluster. So I've got a terminal. I'm on an Ubuntu machine. One of the benefits of Snaps is that it's really a cross-distro package format. So what I'm doing today on Ubuntu runs on like Debian, Gentoo, and Arch, and Fedora, and like a few other desktops and Linuxes. Very soon the project's aiming to add things like Mac and OS X support, and even Windows support. So there's still some areas to move through for those, but that's kind of an aim, is just to be consistent across all those desktop experiences. So I'm going to type this, and then I'm going to use sudo because that's what we're doing to install a package, and I'm just going to bump my terminal a little further down. I'm going to opt to install from Edge, and I'll talk about what that means in a second. So what the team does is they publish various releases at various channels. So Snaps kind of come with this idea of a channel where there's an Edge channel that's currently 1.11.1. There's a beta channel, which is kind of the beta releases. There's a release or candidate channel. Then there's a stable channel. Since this is really a beta software at the moment, there's still some things to be worked through. It's still not like a totally 100% ready to be used. We're kind of limiting it to the Edge and the beta channels. So you'll notice on the website it says to use --beta. That's 1.11.0. 1.11.1 is in Edge, which I'm electing to install today. Cool. Once that downloads, it goes and sets up all the confinement and security profiles, and I've got a 1.11.1. So what this does is it adds a MicroK8s command with a bunch of prefixes or suffixes rather. So for example, I can run microK8s.kubectl, and we'll see that it's a totally empty Kubernetes cluster that's still booting up. There we go. No resources found. So Now that all the daemons are running, we can poke and see that they are just systemd daemons running in a highly confined and constricted fashion. I can enable certain add-ons, so by default it gives you a very empty Kubernetes, but if you're doing things like DNS, like the rest of the world, and some other pieces, you can enable these add-ons, like I want DNS and dashboard for sure. These will kind of enable DNS, make sure the kubelet that's running is enabled with the DNS setup, run those pods, enable the dashboard, set up any additional auxiliary services that support those things. And if I run all namespaces again, we'll see like there are some pods booting up. This will take a few seconds, of course. And I will have kind of those additional services you'd expect running in a Kubernetes cluster. From here, there's really no limit. The microkates.kubectl command allows me to interact with it as if I was using kubectl on my host system. It also doesn't interfere with my host kubectl. So I have my own kubectl. If I run get pose right now, it's a totally different deployment off somewhere else in the world. But if I use the namespaced microkates one, I get just the access to there. And if you feel really ambitious and you don't have a separate kubectl installed, you can do things like snap alias microkates kubectl to your host system. So your host kubectl will be that. Most of you probably already have a kube control installed, so it's not really necessary. I'm going to wait for these things to boot up. Almost done. I'm going to get my services as well. And then we're just going to browse over to the dashboard once it's running. It's a little smaller. And I'll be able to pull up the dashboard. From here, because it's on my host system, the cluster IP is totally accessible to me on my browser. If you're doing this in a VM, you can just forward this cluster IP address out to your host system as well. Let's see, DNS is still creating. Dashboard is running. I should be able to pull a dashboard up even though it won't be complete. So if I go to the services dashboard cluster IP address, I think I need to wait for kubedns to finish, but this will load up the Kubernetes dashboard. Give it a second to finish. All right, it'll respond in a few moments. While it's waiting, that's effectively the project that really is there to aim to be a super functional, lightweight Kubernetes. When I'm done with this, I can run the microkates.reset command, which will reset everything back to a blank state. So if I went and tweaked command line arguments, or if I went and modified the pods running, I can kind of go back to a resetted state there. And then also, if I'm done with it completely, I can just snap remove, and the entire system goes away. It's nice because it won't touch or modify any services running on disk. It won't modify any of the actual files on my host system. They're super isolated, but again, without needing kind of an extra VM layer on top of there where that might be heavy, especially for my laptop, which is a poor little T430. Running VMs, even just one, tends to overtax it a bit too much. So let's try this one more time. If not, let's see if we can hit the API address at least. Or I can just silently weep to myself for using Edge stuff in a demo without super testing it. Oh, you know what? Ports are super important. Oh my gosh. Hey, look at that. There's some ports. It's almost as if I fooled myself. Haha. So yeah, ports are super important as well. There's a myriad of additional add-ons that the team's working on, things like enabling cert generation, storage enablement, ingress controllers, if you're into that. So all those things are kind of coming. But at its core, this is what you get. It's just a super lightweight Kubernetes. That's microkates.
All right, thank you, Marco. Do we have any questions? All right, Marco, yep, it looks like we've already got a link in the minutes, so awesome, thank you. And if anybody has questions and wants to follow up, Marco's also on Slack. So, all right, thank you very much, and we will carry on.
Thank you, Tim.
So next on our standing agenda, we go through a little bit of an update on current release happenings. So I also happen to be the release lead for this current cycle, 1.12. And the main thing that I would note right now is that feature collection is underway. I've got a couple links in the meeting minutes there to existing issues that have been labeled for the milestone 112 and then the features repo as well. We're asking SIGs right now to be actively getting that information up to date. And our features lead, Stephen Augustus, is interacting with
আমি একটা meeting join করলাম.
And also, I didn't mention at the top of the meeting, but I think this is a good opportunity to remind about it. If you are not speaking, please mute your microphone. The other thing to note for 112, the feature freeze, July 31st. So that's, what is that, 12 days away? That's our next major milestone in the release. So just a reminder that that is coming up. And if we have Anirudh on the line, I'd like to get an update on 1.11. We have 1.11.1 just came out basically yesterday.
Yeah, here. So on 1.11, it was a bit of a struggle, but we got it out. It was planned for the 16th, which is Monday, but then we ran into some bugs in, a cherry pick that had to be reverted because it was causing a bunch of failures in kubeadm blocking tests. So Tim St. Clair from Heptio helped us out a lot there. And then once we got that out, we had a bunch of other issues with the release itself, especially around like pushing images, etc. There's a new staging bucket for the GCR images that we ran into, which ate up about a day. But now, I think since yesterday, all of the images are usable. People are creating clusters, and it's all working fine. The major features that went out that I noted were removing the defaulting of the CSI file system type to ext4, which should be a no-op. The Kube API server, the priority admission plugin is now enabled by default, and system node critical and system cluster critical priority classes are limited to the Kube system namespace, which is way safer. And then among the bug fixes, there was image garbage collection was disabled by mistake in the kubelet, and that's been fixed as well. Yeah. A whole bunch of thanks to a lot of people on SIG release who helped push the debs, the RPMs. I have some documentation fixes to go in to help the release process in the future, but I think the next one should be smoother.
And I guess it's worth noting, Anirudh, and then also on 112, our branch manager, Doug McAckern, these two folks are the first time we have volunteers outside of Google doing this portion of the release process. And we're experiencing a few hiccups, but we're trying to rapidly work through and get some solid updates to the documentation so that this is something that's decoupled from Google going forward. And I think quite possibly as of yesterday, we have what's hopefully the last issue highlighted and a resolution in the works. So in the coming weeks, this will hopefully be a little more tidy. Next on the agenda is we started, I think, in the last meeting adding a KEP of the week, and this week we actually don't have one. But if anybody has a KEP that they're working on or is aware of and would like to get a little more information or conversation about it, ping the KEP owner, remind them that the community meeting has this slot for a bit of discussion on KEPs, and it's a great opportunity to get a little bit broader audience on a KEP that's up and coming. So next up is our SIG updates. We typically have 3 SIGs who provide an update on the latest happenings and then do that quarterly. So if you're attending this meeting on a quarterly basis, you get a little insight into what's going on in each of the SIGs. So our first one today is Sig Big Data, and we'll hand it right back to Anirudh actually for that one.
Yep. So because we actually did an update pretty recently, so this is very much incremental. So I don't have slides for this, but I'll speak through it. So Sig Big Data, we deal with big data workloads on Kubernetes. So there's 3 or I guess 4 different projects that we've been focused on. The first is Spark and porting that over to Kubernetes, making it more container native, which is like changes both on the Spark side and on the Kubernetes side. And there's Apache Airflow, which is a DAG scheduler that is pretty popular. So there's work on that. There's a Spark operator, which is a Kubernetes-style operator that we've built on top of Spark, and there's HDFS support. So on the Spark front, there's the Spark 2.4 release. There is a code freeze for the 2.4 release. This is on the Apache repo on the 1st of August. So we're all heads down working towards that. The major features to expect this time around are support for Python. This has been a huge ask from the community. Pretty much everyone that we met at Spark Summit was asking about this. There's client mode support. So this is enabling notebooks like Jupyter and Zeppelin to run on top of Kubernetes and like talk to Spark directly. Lots of testing's gone in this time. We've merged in like a bunch of integration tests. I think at this point we could confidently say that we're, it's good, stable functionality. We removed a bunch of things like init containers were used to download dependencies before. We're using more Spark native constructs. A whole lot of stability fixes, especially around like the controller logic. So we've tried to emulate the way Kubernetes does controllers. So trying to remove all the places where we were edge triggered and making it more level triggered and pretty much similar to how stateful set or deployment operate. And then of course, beyond 2.4, there's a whole lot of work lined up as well. People want to customize their pod templates as they're submitting jobs on to Spark on Kubernetes. There's dynamic allocation, elasticity. There's highly available driver where people want their Spark jobs to fail over and then restart back. That's something we haven't addressed yet and might actually need features on the Kubernetes side. And finally, there's support for R and Kerberized HDFS. So this is future work beyond 2.4. On the Airflow front, we had a blog post that went out on the 28th of June, which describes how to run Airflow on Kubernetes. We're still waiting for the official release of Airflow, which has all the Kubernetes bits baked into it. Spark operator, I think Yinan's on the call. He's probably the best person to take that. Yinan, are you here? Oops. Okay, looks like he couldn't make it.
No, I'm here.
Okay, awesome. Yeah.
So on a Spark operator side, so we actually recently added mutating animation webhook for pod customization. So basically it supports things that Spark itself doesn't support yet, mounting volumes or setting affinity or setting Spark security context, those kind of things. So it's actually replacing initializer that operator was using before. So the reason is the mutating webhook is beta, but initializer is alpha. So that's one of the main things that we have been adding to the operators in the past couple months. And and also we are adding support for Python into the Spark operators as well. So which is coming in Spark 2.4. Those are the major new things that we've been adding to the operator. So.
Yep, thanks, Yinan. And lastly, HDFS, we're just assessing demand and seeing how to make progress. There's a chart out there. I'll put up a link to it in the notes. So if anyone's interested in seeing fully containerized HDFS and seeing if it suits their use case, then please do leave a comment on there. That's all.
All right, thank you, Anirudh and Yinan. That was Sig Big Data. Next on the list today is Cig Multi Cluster, and Quentin Huell, I see you on the line. I think you're muted. There you are.
Apologies, I'm here again. Hopefully you'll be able to see. Can you see those slides?
Yep, it's coming through. Thank you.
Excellent. How do I project here? Okay. Can everybody see?
Yep.
Awesome. Okay, this is going to be a lightning tour of Cig Multi Cluster and where we are today. Pretty high speed, so please excuse that. So we're just a reminder, we're focused on solving common challenges related to the management of multiple Kubernetes clusters and applications that run across multiple Kubernetes clusters. Two main drivers behind this are cluster outage resiliency. So if you have your applications running across multiple clusters, you can be resilient to cluster outages, and also the ability to span across multiple cloud providers, so-called hybrid cloud. We have three main projects, sub-projects at the moment, the biggest of which is Cluster Federation, currently on version 2. We also have a cluster registry and multi-cluster ingress project. Quick reminder to those of you who may be new to the show or not know what Cluster Federation is. That's one of our bigger projects. It basically gives you the ability to interact via a single API with multiple clusters, either for the purpose of managing those clusters or for managing applications that run across them. And the clusters themselves can either be all on the same cloud provider or across multiple cloud providers. The status of Federation, so we did a V1 a while back. It was mainly a proof of concept. It was APIs strictly consistent with Kubernetes, with annotations to add the additional bits that are necessary for multi-cluster management. And it's been forked and used fairly extensively by CERN, eBay, and others. But we don't plan to develop that any further. It was mainly used as a proof of concept to, just prove out some of the ideas we had. Federation V2 is where all of our development effort is focused at the moment. That sort of change of focus there is creating decoupled reusable components that people can use independently of Federation as a whole, and providing reference implementations of the APIs and controllers for that. We did release an alpha version in just a few weeks ago, which has full feature parity with V1, barring a few minor disparities, but otherwise it is essentially does everything that V1 did, but with our new architecture. We plan to have people use that in the next couple of months, finalize the APIs, declare it beta, and hopefully move to GA either at the end of this year or beginning of next year. The main code contributors at the moment are Red Hat and Huawei, and soon will include IBM. Highlights of the V2 Alpha. So we have a control plane based on custom resource definitions. So it is no longer necessary to actually build a completely separate Federation control plane. The custom resource definitions are installed into an existing Kubernetes cluster, so you don't need to run separate API server, etcd, etc. There's also a single generic implementation for all Kubernetes types to provide basic, simple federation. So if you need to propagate any of the Kubernetes types into more than one cluster, you can do that. There's a standard implementation that covers all types with simple per cluster customization. So for example, if you wanted to deploy a replica set across multiple clusters and all you wanted to do was change the number of replicas in each cluster, it's pretty straightforward to do that. It also has a bunch of higher level controllers that sit on top of this basic infrastructure to provide more sophisticated active management across multiple clusters. So you can do active migration of replica set and deployment replicas between clusters, for example, to handle individual cluster failures. You can do active management of federated DNS records. So if you have the same service deployed across multiple clusters, there's a controller that will automatically configure DNS for you, not only to expose all of those services, but also to manage outages. So if a particular cluster goes down or the service becomes unavailable, let's say all the pods crash, the DNS records will automatically be updated to direct traffic away from those clusters. There's also active management of jobs across clusters, for example, to make sure that jobs can be preferentially directed to clusters that have available capacity to minimize the completion time, and things like HPA, horizontal pod autoscaling, be able to manage global limits of HPA across multiple clusters. And all of this also uses one of our other sub-projects, the cluster registry. So there's a standard way of registering and exposing clusters to users. Just to give you a flavor of the kind of stuff we're working on in the next few steps, we don't yet have federated status, so it's not possible at the moment to get a consolidated view of the status of all of your objects across multiple clusters, which we're working on. It's also not possible to get a single consolidated view just the ability to read all of the components, or rather API objects across multiple clusters and get a consolidated list, for example. So we're working on that. It's not currently easy to co-locate a bunch of different typed objects into the same set of clusters. So that's, you can think of that as affinity. If you wanted your secrets and your resource and your replica sets to land in the same clusters, it's a little tricky to do that today. There's also been a requirement for partitioning cluster selectors by namespace. So, for example, dictating that a particular namespace always lands in the same set of clusters. And there's no RBAC enforcement in the federation layer yet. It relies on RBAC enforcement in the underlying clusters, but we don't yet have, and we're busy working on enforcing RBAC in the control plane of the federation. How can you help? So we would obviously like to have as many people as possible use the alpha release that we've just put out this month. Give us some feedback. Let us know if we're heading in the right direction. If you think there are any useful changes we could make to the APIs, now is the time to do it before we declare it beta. There's a link to the release there. You can go and find out where all the bits and pieces are that you need. As I mentioned earlier, one of our core goals has been not only to create a consolidated federation control plane that works as a whole, but also to create reusable components. So we have a cluster propagator, we have per cluster resource customization, we have this DNS auto configuration tool, and a variety of others. So you can actually take those individually and use them in other use cases as well, and we would welcome people to do that. And of course, as for everybody, we would love people to contribute further designs and code. If you want to pick some things off our roadmap or add some new items to the roadmap that you would like to work on, we would definitely welcome that. As I mentioned earlier, we have a couple of other sub-projects. Cluster registry, this is reasonably stable and complete at the moment. It is used in Federation v2, and the main code contributors there are Google and Red Hat. Multi-cluster ingress is another project primarily being worked on by Google. That is reasonably, I was struggling to get a more up-to-date status report there, but basically that exists, and you can go and look in the repository for that. And that's about it for me. I think my time is probably almost up now. Any questions?
I had a quick question about the cluster registry. I was curious what its relationship is with the cluster API subproject.
I'm not an expert on the cluster API. I believe that is to build clusters. Cluster registry is just to declare that clusters exist and be able to list them and have a common repository for all the clusters that exist.
Okay, so just, you mentioned like CRDs in the cluster CRD slide. So just to be clear, it sounds like there's one API object I would use to describe how to manage my clusters in the cluster registry, and another API object I would use to provision or manage an individual cluster. Is that right?
I believe that the cluster API is to create clusters, although I'm not an expert on cluster API. Okay. And the cluster registry is for people wanting to use clusters that are already provisioned.
Okay, thanks.
And we could possibly do a little better on disambiguating those two terms.
Yeah, sounds like there's a lot of overlap. I personally am confused, but I don't need to go on here.
Any other questions? All right, that's me done. Thank you.
Thank you, Quentin. So our next SIG is SIG scheduling, but Bobby is not here yet. He said he would be joining roughly now.
He's here.
Meeting, oh, you're here. Yeah, so this meeting overlaps with SIG scheduling, so it's a bit of a conflict. And okay, Bobby, I'll hand it off to you. Thank you.
Okay, sure. Yes, so I have a few updates about SIG scheduling, and I assume this is these are supposed to be the updates for 1.12, right? Because we also have one like quick update about like 1.11. I can actually start with that. So
yeah, that's fine.
Yeah, so one of our biggest features in 1.11 is pod priority and preemption, which is moved to beta in 1.11 and is available by default. We have improved the feature, made it a little bit more restrictive in terms of potential abuse in the clusters, basically preventing users from creating very high priority pods anywhere they like. And we've basically changed that policy to let users create high priority or system level priority pods only in kube system namespace in 1.11.1. So it's going to be available then. And with that, we are hoping that this kind of like backdoor is closed now. People cannot really create very high priority, or untrusted users cannot create very high priority pods in any cluster they desire. So with that, I would like to go and give you an update about items that we're working on for 1.12. Part of our focus in 1.12 is improving performance. We have like a couple of interesting features that we are working on. We have improved our equivalence cache, which is a way to improve performance of the scheduler. The idea is that once we have evaluated a pod on a certain number of nodes in a cluster, if another pod with similar spec arrives and nothing on those nodes has changed, then it's likely that the same scheduling decision that was made before, or basically feasibility checks of the scheduling decision that was made before, is still valid for this pod. For example, if we check that the pod fits on a particular node and that node hasn't changed, another pod with similar spec can fit on that node that we had evaluated before. This feature existed in the scheduler, but the implementation was not ideal. So we changed the implementation. In the past, before changing the implementation, we were not seeing much improvements. But now that we have changed the implementation, we see significant performance improvement. So far, we are seeing about 3x performance improvement in clusters where a lot of similar pods are created. And this is actually something that happens a lot in many clusters. When you create, for example, a large replica set or similar collections, there are lots of pods with similar spec that are created in a cluster, and this can improve performance of the scheduler. Another area that we are working on is gang scheduling. We are still working on designing this feature. Recently, Klaus, the other Sig lead, has created this proposal. We are still trying to refine the proposal, but it's out there. If you're interested, you can take a look and comment on this. One other area that I have been working on was creating a scheduling framework. The proposal is out, but I am thinking now to change the directions a bit. So in that proposal, I have proposed to build another scheduler from scratch and make it like a framework. But now that I am thinking more about rolling it out, building the scheduler, building tests and everything for it, I'm thinking that we may be able to bring some of those ideas from the scheduling framework to our current scheduler, and in fact improve our current scheduler design instead of just building something from scratch. So that's another area that I'm contemplating. There are a couple of features that we are moving to beta. One of them I've already talked about, that's equivalence cache, which is improving performance of the scheduler. We are also trying to move tainting node by condition and taint-based eviction. These are two other features that we would like to move to beta in 1.12. And we also, as a part of pod priority and preemption work, we have added a feature which is currently in alpha in 1.11, and that's scheduling daemon set pods by default scheduler. So before 1.11, daemon set pods were being scheduled by the daemon set controller. But after we introduced preemption in the default scheduler, we would like to also have these daemon set pods be scheduled by the default scheduler. That feature is built, it's in alpha. We are improving tests and moving it to beta in 1.12 as well. These are pretty much most of the items. There is one incubator project, the scheduler, which is actually helpful in rebalancing resources in a cluster. We would like to, that's the plan basically, that we would like to move it to as a standard component and graduating it from incubator in 1.12 as well. We haven't seen a whole lot of progress on this point, but we will see if it can be graduated to a standard component in 1.12. These are all the updates from my side.
All right, Bobby, thank you. Do we have any quick questions for Bobby? All right, then we will carry on. The next section in our standing agenda is announcements. We start with shout outs, so sort of thank yous from community members to community members. And if you haven't seen it, this is an actual channel in Slack, on the Kubernetes Slack. It's #shoutouts, pretty straightforward. And each week we collate the shoutouts that have been given, and we just kind of give them another bit of amplification here in the community meeting. So this week we have from Jeremy Rickard a shout out to Morgan Bauer for really pushing to make Service Catalog use PROW and to improve our PR reviewing and testing process. So thank you, Morgan. Christoph Blecker has 2 shout outs. The first is to Matt Hikes, who has been very active in test infrastructure recently and has been making a number of different contributions, from fixing bugs, adding new features, and automation. He's been eager to help and has stuck with some of the more complex changes that require many comments and interactions. A reference to some bike shedding that was happening there as well, I guess. So thank you there. And a second from Chris Blecker to Nikita. I could easily stop right there, as her many contributions to the project really speak for themselves. I want to call out through the little chopping wood and carrying water tasks she does that may not be as obvious, like ensuring that stale issues are reviewed, either closed or marked as still relevant, or welcoming new contributors with an emoji or 2. These kinds of things exemplify what the Kubernetes community is all about. Thank you very much there. Ben Elder has a shout out to Quang Nguyen for continuing to send test infra fixes and pushes and fleshing out PR status page long after his internship. Hopefully we start using the PROW PR status page more widely now, thanks to all the hard work there. And a shout out from Aaron Krickenberger, shout out to Ben the Elder, and I will second this one. Thank you very much for all you've done this week helping push out the Kubernetes 1.11.1 images, fixing a symptom there, but also driving beyond just the symptom, getting the appropriate folks within Google involved to ensure there's now a team owning a better solution to the problem, actually fixing the problem. This is the continuation of the progress towards decoupling google.com as a requirement for release, as mentioned earlier in the 1.12 and 1.11 release update section. So thank you very much there. This is quite a big deal. And then we have one other announcement that's been tossed into the meeting notes. In just the last hour at OSCON, which is happening right now in Portland, Oregon, they do apparently something sort of like an Oscars awards, and there was an award for most impact, and that was given to Kubernetes this year. So a big shout out there to the community, and thanks for everybody who's making impact in the cloud native space by contributing to the Kubernetes project. And with that, we are at the end of our agenda, and we have about 20 minutes left. So unless anybody has any questions that they would like to pose to the broader community here briefly, I think we can go ahead and call the meeting, and thank everyone for attending.
I have a quick request, Tim.
Mm-hmm.
If people who talked today mentioned links or proposals, I've left a little, like in square brackets, link here places for you to put the link. If you could go in and fill out your links if you haven't already, that's super useful for people reading the meeting notes after the fact that might not necessarily know where a particular proposal lives or a particular repository exists.
And a huge shout out back to Solly there. If you haven't been following along in the Google Doc during the meeting here, he's scribed 4 pages of notes on what was discussed here. So awesome recording there. Thank you very much. That's hugely valuable to the community. Folks who weren't able to attend, who come back and glance through those minutes or watch the video to get a little more context. Thank you very much. And everybody who can contribute to that, the speakers, or if you're familiar with the area as well, to drop the links or the additional clarifying information there into the minutes. It's very, very useful. Thank you. All right, with that, thank you all for attending the community meeting, and happy Katesing.